So matrices, again, day 1 of 2, but you guys watching at home, there won't be a video tomorrow because we'll cover everything we need. Actually, there may be a going over homework video, but there won't be any new notes for tomorrow. So write down these 3 matrices, and then we'll talk about how to use the calculator to find stuff, because everything is going to be in the calculator in this unit. Copy those down. So first thing we'll talk about, it's not really notes, it's just doing it, is inputting it into the calculator. So grab a calculator, see if you can find what button would be a good one to push for this unit.
That matrix button?
Yes, there's a button that says matrix on it. So
No way.
hit that button.
Really?
And then if you make it that far, there's still a couple things to be careful about. Names is if you want to use the matrix. Math is stuff that we won't even get into. Determinant, transpose, dimensions, and lots of other stuff. We want to edit. So we want to edit matrix A. Matrix A is not a 3x3 matrix. That's in there from last period. Edit is across the top. Scroll over to edit. And then hit enter for edit A. Now, is matrix A 3x2 or a 2x3? It is a 3x2, but even if you forget that and you think it's a 2x3, you quickly realize, whoops, it's not a 2x3. So getting the row column thing backwards, it's not really a big deal because right away you can tell that you got it backwards. We'll make it a 3x2. And then we'll put our matrix in there.
And it'll solve it for us?
And it'll do, well, there's nothing to solve. Right now it's in there. We'll do stuff with it in a moment. So double check, make sure all the numbers are right. Because the calculator doesn't make mistakes. The only mistake will be if you type in a number incorrectly.
What is this use?
All right, second quit. It's because you have to exit out to put another one in. And then go back and put in B and C. So matrix, go over to edit, down to B. Matrix B is a 2x2. Or -1, -2, 3. And for matrix B. Again, take that 2 seconds it takes to double check to make sure the numbers are in there correctly. Second quit. Go back in and edit matrix C. And that one, 2, 4, 0, -3. All right, so that's pretty easy. Finding where they are and how to put them in. Tibet, I hope you're doing this with us. This is a prime opportunity where you're going to ask me on test day some question about the calculator, and I'm once again not going to answer you. So I hope you're typing things into the calculator as well as watching Tiger. You're doing both over there. All right, we'll use the calculator to do whatever we need it to do. So let's do B plus C in the calculator. So second matrix. Now I don't want to edit B, I want to use B. So I'm not going to go over to edit, I'm just going to scroll down to B and press enter, and that puts it on the main screen. And then plus, and then same thing, go get matrix C. Second matrix, scroll down to C, B plus C. Calculator does all the work, not that it's very hard to add matrices. So adding them, it probably is easier to just add them on your own, because adding them, you just add the spots. 4 plus 2 is 6. Negative 1 plus 4 is 3. Negative 2 plus 0, 3 plus 3. Yeah, you just add like by position. Multiplying doesn't work that way though, so it is easier to use the calculator for multiplying. So if we want to do A times C, move my face out of the way there. Same thing, go get A, and then do times, and then go get C.
How does multiplying work in like math or physics?
I'll tell you in a minute. Oops. A times C. You can put the multiplying symbol in between them, or you could not, because it still means multiply. Now, multiplying by hand is harder because it's a row by column thing. We're not even going to worry about it. We'll let the calculator do it. All right, why don't you try C times A? See what you get. Mm-hmm. Did you get an answer for C times A? You get an error. You know what dim means? What dim stands for? Dimensions. A dimension mismatch.
Is it because you have to have a bigger one for the small one?
Okay, here's why. A is 3 by 2. C is 2 by 2. If you want to multiply matrices, the inside numbers have to match. If they don't match, you get a dimension mismatch. C times A is a 2 by 2 times a 3 by 2. Dimension mismatch. That doesn't work. You don't really have to know all that, but that's why sometimes you can multiply matrices and sometimes you can't. And with numbers, you know, the order doesn't matter, right? 5 times 2, 2 times 5, same thing. It matters for matrices. So be careful with matrices.
Well, you know if you did it wrong, because you'll get a dimension error.
Right, but I do want you to see that because there are some on the worksheet, on the test or quiz, that there's no answer to, that you can't be done. So it doesn't mean you're doing it wrong, it just means you can't do that. All right, let's find the inverse of matrix B. And again, that can be done by hand, but it takes a little bit of work. We'll let the calculator do it. Second matrix. Go get matrix B. And then use the little -1 button. And he does all the work. 0.3, 0.1, 0.2, 0.4. Nothing wrong with those answers since they're tenths. Those are easy decimals. But if you get weird decimals, then it might be better as a fraction. I think most of you are familiar with the math frac button that turns crazy decimals into sometimes simple fractions. Well, it works here too. So hit the math button. The first option is turn it into a fraction, and it takes that matrix and turns it into a fraction matrix. 3/10. So for simple decimals, for terminating decimals, decimals are fine. But if you got weird decimals, it might look better as fractions. I don't think the worksheet specifies, which means we don't care if it doesn't specify. This one is probably easier to leave because those are easy decimals. But when you get the weird decimals, you might want to math frac, and you might end up with some simpler fractions. We can skip that last one. That's an easy one. Let's jump ahead. Let's Roman numeral 3 here. Solving equations. With matrices. This is kind of an easy one, but it looks crazy. Once we know how to do it, it's not really that hard. So copy all of that down. It looks kind of weird. X negative 1, negative 4, 3, plus 2 times 1, negative 4, 2y. 7, negative 9, 0, 11. Now let's say I want to find what x is. Well, when you add matrices, you add sort of by position. So it's top left plus top left equals top left. I do have the times 2 there, so I do need to be careful. So x plus 2 times 1 equals 7. So that's how multiplying with a number works. You just multiply it to all of them. Multiplying a matrix times a matrix is a whole different deal that we'll let the calculator deal with. Hold on, let's go one piece at a time. X is 5. And yeah, there's y. That's in the bottom left. Or the bottom right, excuse me. But you guys are right. There's a 2 out front. So it's kind of sometimes tricky that you focus on the bottom right and you forget that there's a number out there. 3 plus 2y equals 11. And John, you were right. I think you said y equals 4. You're right. Not really hard. Just make sure you're careful and pick out the right spots. Somebody second period missed one of those, but they had grabbed the wrong spot. And so as soon as I pointed out, they're like, oh, dumb mistake.
Did they grab the negative 4?
I think they did the negative 4. So it's like, if you need to color code it, if you need to say it, just be careful. That was one type of equation. The next type is solving systems of equations. So that would be like x plus y equals 2, 2x minus y equals 15. Okay, so one way to solve this is to get y by itself and substitute it into the other equation. That's sort of what we did on the last test when you were solving for t and then substitute t in. So that's one way to solve this. That's called the substitution method. You can also do the elimination method or the combination method where you add the two equations. This one would be set up well for that because the y's would go away and you get 3x equals 17. That's one method. The method we're going to use is maybe harder for a 2 by 2 system, but when we do a 3 by 3 or a 4 by 4, you don't want to be doing anything by hand. You want to let the calculator do it all. So here's how we let the calculator solve it with matrices. First, we get a matrix of the coefficients. So you're just going to pick off the coefficients and put them there in order. So not the x and the y, just the numbers that are in front of the x's and the y's. And be careful with the negative. Make sure you include the negative. That second y has a coefficient of -1. Then we have a variable matrix. So this is a little bit weird. It's one matrix, but it has two values in it. So both variables are in the variable matrix. So when we get an answer, we'll get both answers at once, because we're going to get an answer for this matrix, but it will include x and y. And then that equals, there's got to be a better name than the answers over here, but 2 and 15. Now, we don't do it by hand, but Ryan, you ask, how do you multiply matrices? You multiply row by column. This is what makes this work. Row by column. So you do this row times this column, and you go in order, so that would be 1x plus 1y equals 2. And this row by column would be 2x plus -y equals 15. So that's sort of the justification for turning two equations into one matrix equation. Now, we don't really know that. The calculator takes care of it on its own. All right, let's say, so separate problem here. Let's say we have 5x equals 13. What would you do to solve for x?
Divide 13 by 5.
Divide by 5. In matrix land, you can't divide. You can only multiply. So if I told you you had this problem, but you weren't allowed to divide, you'd multiply by 1/5. You'd say, I'm smarter than that. I can work my way around. And if you really wanted to be cute, you might do 5 to the -1. I mean, no way anybody would write that, right? You would divide by 5. But this is the same thing as dividing by 5. Okay.
Okay, on the calculator, how do you get rid of the matrix that's in there?
Okay, that's a good question. Once you put one in there, it's pretty much in there, unless you wipe out the whole calculator. Now, if you need to change it, that's not a big deal. You just go edit and change it. So you're right. Once it's in there, it's going to be in there until you
don't need to,
like
delete it?
clear the memory.
No, you don't.
But you don't need to delete it.
And
So
how do you get it to be x and y in there?
oh, you're not. That's a good question. How do I get x and y into a calculator? You don't. Just like when you're using a calculator to solve 5x equals 13,
So where do you get
x never goes into the calculator. Into the calculator goes 13 divided by 5. Or if you wanted to be fancy, the inverse of 5 times 13.
So you don't have to put that matrix in the calculator?
You will not put this matrix in the calculator.
You put the second matrix?
You're going to put a and b in the calculator. In fact, yeah, I guess I shouldn't even say that goes in for x, because it doesn't really. But a and b need to go in there. Now, using this kind of as a guide, what do you think we should do over here to get x by itself if we're not allowed to divide by a matrix?
Multiply by the negative.
Multiply by its inverse. And this is what the calculator will do for us. So let's put a and b into the calculator. So edit matrix A. So when you go to edit and change it to 2 by 2, just go change the values. And then go edit matrix B. 2 and 15.
Why do you do the inverse of A?
Why do you do the inverse of A?
Yes.
Because I can't divide by A, because you can't divide with matrices. So
Oh, gotcha.
it's the inverse is sort of the opposite of multiplying. Matrix A inverse times matrix B, and I should get two answers. I should get an X and a Y. Ooh, ugly numbers, so this would be a good spot to go math frac and get nicer numbers. So we get 17 thirds, negative 11 thirds. But I don't want your answer as a matrix. I want it as an ordered pair. So 17 thirds, comma, negative 11 thirds.
It's not going back to the main screen.
So did you exit? I guess I don't understand your question.
Like, so you do second matrix, edit one, and it just pulls back there.
That's okay. That's why you're practicing now. Some people aren't.
You want us to write it as an ordered pair?
So I want your answer as an ordered pair. I suppose I'd be okay if you wrote it out, but why would you want to write it out like that? An ordered pair would be an easier way to go. Like, the problem didn't start as a matrix problem, so I don't want a matrix answer. I want X and Y as an answer. All right, one more thing. Sometimes weird things can happen if we're looking for an intersection of two lines. So, like, I guess big picture, what we found on this last page was, where did those two lines intersect? That's what we were looking for. But there's a couple of cases where you have two lines and they don't intersect at one spot. Can you think of a special case of given two lines that don't have one intersection? So parallel is one option.
What's it called? The asymptotes?
So parallel lines have no intersections. And there's one more. You might not think of this one because this is kind of a weird situation. It's not that they don't have any intersections. It's kind of hard to draw because if it's the same line, it's like it's the same line. I don't know what do you want me to say? It's like all the points on the line are the intersections. So you'll know it's one of those if the calculator gives you an error. But if you get an error, then you got to figure out which one it is. So let's do that one off the worksheet together. So we'll look at worksheet 1. I think it happens on number 10. But I'm going to hand you the worksheet and then we'll do number 10 together. So look at number 10. And by the way, this is the work that I want to see. I know it's all in the calculator, but I do want to see you set up the matrices. After that, I know what you're doing, but I do want to see that you set up the matrices. Then when you do A inverse times B, you get an error. So this is how you know that it's one of the weird cases.
Singular mat.
Singular mat. Mat stands for matrix. Singular has a long explanation of what that means, but singular matrix, there's an error. So now I need to figure out, are they parallel or is it the same line? Sometimes they're close enough you can tell by looking. Other times, you just solve them both for y and see what you get. So negative 10y equals negative 20x plus 30. So if I divide by negative 10, I get 2x minus 3. So that's the first line. The second line, 6y equals 12x minus 18. If I divide by 6, 2x minus 3. So it's the same line. What would parallel lines look like? How would you know if lines are parallel? The same slope. So for these, you're always going to get the same slope. It'll be a matter of, do they have the same y-intercept or not? So, same line. So if you get the weird case, that's bad news, because then you got to figure out which weird case it is. Is it the same line or is it parallel lines? All right, you know everything you need to do for worksheet 1 and for worksheet 2. So again, tomorrow I'll work some from worksheet 1. Maybe I'll work some from worksheet 2 just for practice, but there won't be any new notes for tomorrow. Look on the back of worksheet 2. There's an instruction that we need to fix. This is on the back page of worksheet 2. Solve each system of linear equation using Gaussian or Gauss-Jordan elimination. No, we don't want to do that. That's a pain. We want to use a calculator with inverse matrices. That's the back of page 2. So do it the way we showed you to do it, not this other method.
But we're not doing that today.
That's tomorrow's assignment. But seniors won't be here tomorrow, so you're all caught up.